Assalamualaikum warahmatullahi wabarakatuh. We are from group 9. We will discuss about multivariate analysis using a multiple linear regression to look at the relationship between several variable and one dependent variable. Me, Lisa, and my partner is Francisca Dewi Resnanda. So for the first explanation will be explained by me, and then I want to explain what is the multivariate analysis. So multivariate analysis is a statistical procedure for analysis of the data involving more than one type of measurement or observation. Uh, it may be also mean solving problem where more than one dependent variable is analyzed simultaneously with the other variable. And then I want to explain what is the multiple linear regression. Okay, uh, we look at the relationship between one effect variable. It's called the variable dependent variable or outcome variable. And then for example are writing score, English score, math score. I think like a score. And then one or more than predictor is called the independent variable. For example, is gender and other. Okay, next, the basic regression equation is, the formula. So the basic formula is y equal a plus b x. Okay, for y is the symbol for dependent variable and x is symbol for independent variable, and then a is the symbol for intercept or the value of y when x is 0, and then b is the same symbol for the slope. Now I want to practice how to use it to analyze multiple linear regression and the SPSS application in the next video. I want to practice how to use SIG multiple linear regression and the SPSS application. So I had to prepare the data for the analysis. I want to copy to all of the data. This is only for example. And then open application SPSS application, and then put in the data in the table in the column, and then click a variable view and give the name, and this is I give the name is type 9 map, and the second gender, and the last is writing school. And then for decimal I want to change into 0 decimal. And then the measure I want to choose where the to know what differences dependent variable and independent variable. I choose for the independent variable. I choose nominal scale. Nominal. And then for the dependent variable, I choose scale. And then back to data view. And for to do the multivariate regression, we can click the analyze and then choose the regression and linear. And then for the independent variable, I put in the rating score. And then for the independent variable, I choose the type, map, and gender. And then click statistic and get the mark estimates and model fit. And then click continue and OK. And then we will write out. And this is the result of the analysis. I mean the result after I do the SPSS application. And then we focus on the table, this table model summary. And then for the first is R. This is a measure of the how will our predictor predict the outcome, but we need to take the square root of R to get a more accurate measure. So the value is 0.792. And then R square is so as the amount of variance in rating score explained by the two predictor variables together. And then adjusted R square, this is the value is 0.613. And then for the table adjusted R square, we can compare the with the rule of thumb. And then if the adjusted R square less than 0.1, that the result is perfect. And then if the R square is 0.1 until 0.3, it's modest fit. And then if the R square is 0.3 until 5, is moderate fit. And then if the data if the R square is more than the 0.5, is the data is strong fit. Now we look at the data. We look at the table now. So this is the adjusted R square is more than 0.5. So uh, we can indicate the data is strong fit, and then the last table is standard error of the estimate, and then we focus on the second table, coefficient, and then the first is column. Column gives the name of our variable. The variable label is constant, is the intercept, and then the unstandardized b for the type mind map is less than uh, 13 13.669, and then gender 11.617, and the coefficient standard error is you can look at this table, and then for the last table is the what is it give us the statistical significance of the relationship between its predictors and the dependent variable. I think that's all for explanation and practice about uh, linear regression using SPSS application. Okay, the next explanation will be continued by my partner. So here I will continue the presentation from Lisa using ordinal and nominal variables as predictors. In theory, regression analysis is designed to be used with continuous variable. Both the dependent and the independent variables are supposed to be continuous. This obviously limits the extent to which this method can be used to construct models that properly explain the variance in the dependent variable. In our example, this means that there are a number of variables we can use, and like all the variables on pupil attitude, or which are ordinal, and the variables that are nominal like gender. And then for the next is linearity and outliers. Linearity and outliers, this method is not called multiple linear regression for nothing. Multiple linear regression imposes a linear relationship on the data point that describe the relationship between the two variables. If the relationship is nonlinear, the model will not fit the data properly. There are many relationships that are not linear, and for example, where we need to pass a threshold to find any effect of, or where the strength of the relationship tails off. Then for the last is multicollinearity. A second major precondition is that our predictor or independent variable must be too strongly correlate with one another. If they are, multivariate analysis will cause serious problem in estimating the relationship between the dependent and the predictor's variable, because it become hard to calculate the individual contribution of each variable when predictor variables are very highly correlated. And we have to wonder whether they are not in fact measuring the same thing and would be better combined into one are very highly correlated. And we have to wonder whether they are not in fact measuring the same thing and would be better combined into one new variable. This problem is called multicollinearity. I think that's all. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.